So good morning, good afternoon and greetings of the day to all the students. Welcome back to our channel Proper Pariksha. So this is the part 2 of 3 of the series of how to design an IC engine theoretical in NX CAD, a parametric design software. Okay, so first of all we'll start with the fixed pin. Okay, now we'll go to the part navigator. And in this video, I'll show you that how each and every component was designed and what are the things which are required and what are the geometrical or dimensional constraints which are required. I will not make each and everything so that the time is reduced, and I will just give you an overlay and I will give you the important concepts behind that. So first of all, we'll take this sketch. I will suppress this. So first of all, we'll make this sketch, and this sketch will be made with the help of the profile tool, like this, like this, like this, and like this. For an arc, we hold the left hand side, we left click, and then we make the arc. Okay. Okay. So then we'll make a circle which will be concentric with the arc, and then we will do dimensional constraints, like we will give the dimension for this, then we will give the radius or the diameter for the circle, then we will give the dimension for this side, and then we will give the dimension for this side. So the dimensions have been written already and the model has been made. So you may look into that. And as for this, if you see that if we try to move this sketch, it will move without distorting any of the dimensional constraints. So it will only move as per its location. So the location, in this instance, I have taken that the center of the circle, the center of the arc coincides or is concentric with the origin. If I will hover over here for 2 seconds, you will see that the sketch vertical axis is present here and the sketch origin is present. So this is the sketch origin, this is the center of the circle, this is the center of the arc, and then the sketch will be fully defined as mentioned over here. And then we will finish that, and after that we will do an extrude for 20 mm. You can do 15, you can do 10, whatever you like. For this example sake, we will do 20 mm. And you can take the limits as value and value. You can also take symmetric value, but for this example sake I have taken value. If you will take symmetric value, then also you will have to put 20. The only thing will be that either side will be 10 and 10 each, and like if you will add it up, 10 and 10 is equal to 20. Okay. Now we will see this thing, then we'll make another sketch that will be perpendicular to the previous sketch. And for that we will do what? We will take this corner, the corner over here, this corner, as the origin of the sketch. As you can see over here, if I will hover over here for 2 seconds, you can see that this is the sketch origin. And after that we will make a rectangle, and after making a rectangle we will make a circle inside that, only one circle, which is this one. Okay. After that we will do what? We will put dimensional constraints on the longer side of the rectangle and the shorter side of the rectangle. You can see 120 and 20 respectively, and then we'll put a diameter for the circle which is 5 mm as of now. So thing which is to be understood is that the thread which has been used, the M6 threaded bolt which we saw in the assembly, that is over here, M6 threaded bolt into 4, because there are 4 threaded circles, holes, so there will be 4 bolts. So for that we are taking 5 mm, because whenever you perform a threading operation on a hole, it requires the hole should be lesser than the diameter of the thread. Okay, so for 6 mm we will take 5, for 8 mm we will take 7 or 7.5, something like that, depending upon the thread. If the thread is 0.5, if the thread is 0.75, whatever it is. Okay, if the is metric coarse, metric fine, depending upon that, the diameter of the hole is considered. So for a 6 mm, for M6 hole, M6 threaded hole, we will take a 5 mm circle. And after that, we will put dimensional constraints using rapid dimension tool with between the center of the circle and the origin in this direction, that is 10 mm, and then in this direction, that is also, you will see, uh, sorry, that is not the case, 10 mm, and for this it is, yeah, so the center and the reference. So now coming to the next point, we will draw two lines. One will be parallel to the longer side and another will be parallel to the shorter side. We will draw from one midpoint to another midpoint and so on. After that, we will use this make midpoint aligned, and we will take this point of this line, start point of line 10, and the second object, the stationary curve, we will take this as, we will take this the midpoint of line 7, and then it will get aligned and you will get the symbol of this midpoint, and then we will do the same operation of midpoint aligned. We will take the start point of this point, and then we will take the stationary point of the midpoint of this line, and then it will get the midpoint dimensional constraint or geometric constraint. It is a geometric constraint. After that, we will take the mirror tool. Mirror tool can be searched over here, or it can be seen over here. Sorry, it can be seen over here, mirror, or it can be searched over here. It will have a mirror curve. We will select the mirror curve. Then we will select the curve, that is the circle, and we will select the line with respect to which it has to be mirrored. It will be this line for this instance. If we have to make this circle, we will select this as the center line after clicking this, and we will note that these two boxes are checked. Okay, this is important. Convert center line to reference and create persistent relation. Convert center line to reference because the line which will be used to mirror the object or mirror the curve will be converted to reference, because so that when we extrude the sketch, the reference line will not affect the extrude in any manner, and the create persistent relation will allow the circle to have the same dimension as that of the curve which is used as a reference for mirroring. So if we will change the diameter of the primary curve, the mirrored curve will also change. That will help with create persistent relation. And then we will get this circle. After that, we will again select the mirror curve. We will note that both the check boxes have been checked. We will select these two, and then we will select the line of reference, that is this. We'll get these two as the desired results. After that, we will get this and we see that there will be no movement of the sketch. If there is any movement, then we will see as to where the movement is. For example, if you see this dimensional constraint that has been made so that the sketch does not move in the z-axis or in the minus z-axis. That is done for this purpose. After that, we will finish the sketch. After finishing the sketch, we will use the extrude feature and we will extrude for 10 mm. This one, and you can see that we will use for 10 mm, and we will use the Boolean operation unite and unite with this body, so that this body and this body becomes one single body. Okay, now second, we will do what? We will take the thread option. The thread option is present over here. Sorry, it is the assembly tab. We will go to the home tab, and we will select this thread tab, and after thread we will select the cylinder that is to be threaded, and then it will take the dimension closest to it. So it was M5, so it will take M6, and then thread length will be, so try to keep the thread length little bit more than the total length. So that is 10, so it will give, 10.5, 11, 12, something like that, so that the thread does not stop midway, because if you will take full, then it will stop midway, and this might look something like not good. Okay, so we will do something like this, and then after that one more thread operation was added. We do not require that, so we will perform the same threading option, threading command on all the 4 circles, and we will get the thread feature. So I'll suppress it so that you can see it. So you see that the threads are made. I have selected the detailed option, not the symbolic one. So if you will select the symbolic, it will only be symbolic, like that dotted line will be formed at the start and the end of the thread. And if you will select detailed, a proper thread looking like thread will be displayed. Okay. So with this we conclude the fixed pin of our assembly. Now, coming to the crank. If we come to the crank, what is crank? Crank is the simplest object which can be made. Much more simpler than the fixed pin, if you will like believe in my words. So it is much more simpler than the fixed pin. Crank, nothing but only take profile, do like that, do like this, do like that, then do like this. So this, and then there will be 2 circles which will be concentric. Then there will be another circle which is concentric. We will put the dimension over here. We will put the dimension over here. The dimension of this inner circle will be the same as the dimension of the inner circle of the fixed pin, because the same fixed pin will be used to combine both of them, or to make them rotate together on the same axis, on the same collinear axis. So obviously the diameter will be the same. So here also we will take 40, we will take 40, and then we will select the length, that is we have taken 80, and after that you can also take either 40, or you can do what, that you can delete it, and you will see that sketch is fully defined, because we have taken this circle, and let me show it to you again. Make equal, select equal radius, and this, sorry, not the motion curve, this will be the motion curve, and this is the stationary curve, and it will get same radius. So we need not write the radius over here also, but just I wanted to write it, so I wrote the diameter over here also, and the radius over here also, and the length. The sketch is fully defined, because if we have not placed the sketch, if you might be thinking, but you see that the sketch origin is concentric with the center of the circle and the center of the corresponding arc. That is why sketch is fully defined. After that, we will do an extrude. First, we will finish the sketch, and after that, we will do an extrude, which will be 20 mm. There will be no Boolean operation, because it is only one single body. After that, we will do edge blend on both the sides, okay, with 1 mm, just to make it look cleaner, and you know that edges are blended so that stress concentration is avoided, so that failure of the tool or failure of the object can be avoided. Okay. Now, after coming to the crank, we will make the connecting pin. Okay, so connecting pin is simply, we need not make any sketch also. We can make the connecting pin directly without going to sketch. So see, first of all, that the connecting pin is only made only one times, but since it is used in 2 places, that is between the fixed pin and the crank, and second in the crank and the connecting rod at the larger diameter side. So there are two connecting pins used. So that is why we have added one connecting pin two times in the assembly. And now making of the connecting pin, as far as it is concerned, we will just take this more and we'll use cylinder, and in this cylinder we'll add the diameter and the height. So if you will see over here, the diameter is 40 and the height is 44. Why 44? Because you see that the fixed pin was extruded 20 mm, the crank was extruded 20 mm, so both combined make 40 mm. So we should have used 40 mm only. Yeah, we can use that 40 mm, but you know that we will do an edge blend operation. As you can see that there is an edge blend operation, and that edge blend operation will take some distance on this side and in this side. So that is why, to compensate for the edge blend, we have taken the length as 44 mm. Now second, we will make a cylinder over here that will be of, I'll just suppress this thing and I'll show you that we'll do another cylinder operation, and we'll select the vector, we'll select a point, the point will be the center of this face, and the diameter will be little bit more. Why we have made it little bit more? So that the connecting pin जो है वो बाहर ना निकले जब हम कनेक्टिंग रॉड और क्रैंक को जोड़ें, और जब क्रैंक और फिक्स्ड पिन को जोड़ें. जनरली आप देखते होंगे whenever a connecting pin is used anywhere in any assembly or in any fixture, it has the लार्जर डायमीटर इंप्रेशन, मतलब कि हथौड़े से उसको मार के उसको चपटा किया जाता है, उसको दबाया जाता है. जस्ट एज यू कैन सी दैट a connecting pin in a chain of a bicycle or in a chain of a motorcycle, you cannot pull the uh, connecting pin out from any of the pair of connecting links, chain links, okay, because both the ends are of slightly more diameter, and in order to take it out you have to either forcefully hit it and then it will get out, and after inserting you will have to again hammer it so that it does not get out. So that is why connecting link or a connecting link, I presume it is said, a connecting link is supplied along with the chain so that none of the connecting pins are tampered with, and that connecting pin is used to join the chain, because it has like something like this, and the chain is inserted over here, and another one is inserted, and a lock is inserted. तो इंग्लिश में बहुत सी चीजें बताना मुश्किल पड़ता है, मतलब आप समझ जाओ तो अच्छा है. और ये सिलेंडर 2 हो जाएगा, ये सिलेंडर 3 हो जाएगा. आफ्टर दैट वी विल यूज एज ब्लेंड, and the edge blend will be used just to make it look more smoother and for the purpose of stress concentration. Although we will not be doing uh, like stress analysis over here, which is primarily done in SolidWorks, but yes, for the sake of design, we will use edge blend so that it looks as real as possible. So this will be 1 mm, okay. This will be 2 mm, the outer ones will be 2 mm, and this one will be 1 mm. Okay, okay. So I think you have got that. So connecting pins we have now made. Now after that we will make the connecting rod. So we have done till the fixed pin and how to make threads in the fixed pin, how do we make sketches, how do we extrude, how do we unite, how do we make a crank, how do we make a connecting pin, how do we use an edge blend, and how do we use the cylinder operation without going into sketch, like we have to make a circle, then we'll have to extrude. So no need of that, directly go to the command tool of cylinder and insert a cylinder. Okay, now coming to the connecting rod part. Connecting rod is also similar to that of the crank, but the only thing is that it is of slightly more length. So I have taken the length to be 400. It is not like something fixed. you can take as per your own preference. The only thing is that the connecting rod should not touch the cylinder while it is assembled and it is in motion. And the second thing is that the length should not be too much, too long, so that and resulting into the cylinders and the piston looking very small and insignificant. So it should be something in middle. Okay, so this one diameter will be 40 mm. We will make a sketch. As you see over here, we will make a sketch and we will make a 40 mm. We will make a arc, like it will have a radius of 30 mm. Then we'll make another cylinder, another circle, and another arc. All this will be made using a profile and circle tool. After that, we'll add the geometrical, we'll add dimensional constraints. So since this is 40 mm, it will be 40 mm, and this will be 20 mm, and this will be 15 mm. Why? There are two questions. Why is this 20 mm? Second question is that 20 minus 15 is 5 and 40 minus 30 is 10. So why is there a difference over here and over here? Okay. Answer this question. We will get to the part of our assembly and we'll see that the connecting rod, the connecting pin, the piston seal ring, and the cylinder. We'll see this and we'll understand that, as you know, that this connecting rod will have a motion, and that motion will require it both to have at least a clearance of 0 rather than having a minus. Either it should have a plus clearance or a 0 clearance. That is like okay, acceptable as far as the theoretical design is concerned. So if you will see this, if you will see the piston, I'll just show you the piston. If you will see the piston and if you will see this sketch, so you can see that the piston has been made and the 20 mm groove has been cut over here, and you can see that 10.5 mm is taken because you know the extrude is 20 mm, so 10 and 10 20. So why 10.5? Just to make it look a little cleaner, nothing else. And 30 mm. So you can see that this is 30 and this is 10, and the whole piston is of 40 mm length. You can see over here. I'll have to finish that, so I'll not do that. Just take my word. 30 and 10 is 40. So just for that we can take 30 and 10. Okay. So 40. So इधर ये वाला लेंथ जो है ये 5 है और ये वाला लेंथ जो है वो भी 5 है. 5 और 5 10 plus 20 30 plus 10 is equal to 40. अगर आप चाहें तो इसको आप बड़ा भी कर सकते हैं. You can keep it 30.5. ठीक है, और इसको आप कर लो 9.5, just to make you understand the reason behind it. I'll finish it and it will automatically update, and then I'll again use the connecting rod, the connecting pin, the piston seal ring, and the cylinder. Okay. So now if you see that there is a 0.5 mm gap between the connecting rod and the piston. Okay, so that gap may be there, may not be there, but that is not a big concern. Okay, so we were on which part? We will come back to the topic. We were at the connecting rod. So the question was that why is this 20 mm? The answer is that the groove taken in the piston is of 20 mm and the connecting pin is also of 20 mm. And if you will take a 40 mm, the piston will be quite bigger, so that is not good as for the design purposes. So 20 mm is taken. And secondly, why 20 minus 15 is 5 and 30 minus 20 is 10? So because the length available over here is only 5 mm, and if you will take 10 mm over here, we will not have much area for this piston slip rings or the seal rings to be, the seal rings to be placed or the grooves to be made. So that was the answer. for the two questions. Now, coming to the M6 threaded bolt, how did we make that? So the M6 threaded bolt was made It was also made only once, and since it was required 4 times, we had it multiplied or copied 4 times. So this is the main part which has the origin as its center of the circle. The first thing what we did was we used a cylinder, we made a cylinder, and the cylinder dimensions can be seen as 6 mm and 10 mm. Okay, because the thread is of 6 mm. Okay, so the cylinder, the male part can have the same diameter as that of the thread, but the female part should have a little bit lesser diameter because the material, when it will be removed, it will get it to 6 mm diameter or a larger diameter. Okay, now the cylinder will be used and made, and then after that, we'll make a sketch on top of the cylinder. Okay, on top of the cylinder, we'll make a sketch, and the sketch will be a regular hexagon. A regular hexagon means that the angle between the two sides is 120 degree. Okay, and the uh, length of each side is equal to each other. As you can see that this is the equal length relation which is over here. We use the equal radius equation, and this we will use the equal length operation. And after using equal length operation, we will use the angular dimension and we will take the angle has to be 60 degree. Okay, so if we'll place it at 60 degree, then we'll have a regular hexagon. And the length of the side is 4.2. That is nothing like standard something or what. I just took it on a hunch, on a whim. So you can take 4 or 4.5, anything like that. After that, what is necessary is that this hexagon will have, like, either you will have to draw lines from any of the vertices or any of the vertices of the hexagon to the center of the origin or to the origin to make it like constrained in a particular place. Or you can do one thing, that you can draw a circle with the center same as the center or same as the origin, and after that you can do what you can do like yeah, you can draw the circle using this method, the three dot method. Take this point, take this point, take this point, and draw the circle. It will touch all the vertices. After that, make it concentric with the origin. Okay. So after that, make it convert to reference. So this will make the hexagon in one place, and it will not allow it to move. Okay. So this was the hexagon, and after that, you will स्केच को एक्सट्रूड करेंगे. कितना एक्सट्रूड करेंगे? 2 mm 4 mm करेंगे, उसको एक्सट्रूड करके यूनाइट कर देंगे, as you can see over here. And after uniting, we will take edge blend and we will apply edge blend over here, and we will apply edge blend over. थोड़ा सा यहाँ पे करेंगे, ये आपका edge blend हो गया. दूसरा और एक चीज हम करेंगे, थ्रेड करेंगे. नॉट फ्रॉम थ्रेड हम लोग इस डायरेक्शन में नहीं करेंगे. Thread will be starting from this direction to this direction, that is from this to this direction. And this will be M6 into whatever you can take, it is M6 into 1. After that, the thread limit will be full. You can also increase or decrease the thread limit, and so on. Okay. So there are many features. You can take the metric course and etc. etc. There are many features over here, so you can use any of them. So this was the method of how to make a M6 threaded bolt. And why did we use edge blend over here? Just to make it look a little cleaner. That is all. And the main thing in mechanical engineering which we have studied, the thing which I think none of you would ever like forget, is that sharp edges lead to stress concentration, which lead to failure, and soft edges or edge blends or edge fillets work lesser edge blends were much better. Edge blends allow it to, or chamfer or fillet allow it to reduce the stress concentration, thereby reducing the chances of failure. Now, coming to the connecting pin. So we made a connecting pin which was D40. So it had one cylinder and two other cylinders which are mounted on either ends. And then we used edge blend 2 mm and 1 mm. And the length was 4 mm greater than what was required, because 2 mm was occupied by the edge blend and 2 mm was for clearance purpose. Okay. So connecting pin D20, we will come over here. तो कनेक्टिंग पिन में D20 क्यों लिया गया, इसका क्वेश्चन का आंसर तो आपको दे दिया गया, ठीक है। इसके बाद हमने क्या किया, एक सिलेंडर और बनाया। उसके लिए हमें क्या करना होगा, इसे सप्रेस करना है। आफ्टर वी सप्रेस इट, after we suppress it, you can see that this connecting pin is somewhat same to that of the connecting pin D40. The only thing is that its diameter is small and length is bigger. Okay. Otherwise, operation wise, it is same. Like the operation of cylinder, then another cylinder, then another cylinder, then edge blends used, that is same. We will not use edge blend over here because we do not have that much clearance. If I will use this clearance, then I will not be able to show you one more thing which is required. Okay, so we'll do only edge blend on the outer side. After that, we will make another sketch which will be perpendicular to the length of the cylinder, and that will be just a simple circle with the just a simple circle, and the circle which will have the diameter of the length of the cylinder, that is 81 mm. Okay, you can see it has the diameter of 81 mm, and we will fix it with the cylinder just so that it does not go here and there. After that, we will finish the sketch and then we will extrude it. And how much will we extrude it? We will extrude के वो पूरी तरह से बाहर की तरफ काट सके। देखो, अगर हम इसको कम करते हैं 20 पे, हमारा हो गया कंप्लीट। तो हमने 40 ले लिया था जस्ट बिकॉज आई वाज रनिंग शॉर्ट ऑन टाइम, सो आई पुट 40 की इट विल डू इट, so no need to calculate because there are many dimensions and I was forgetting some of them, so I took 40. You can take 20, 21, 22, anything. Okay, so after that we will extrude, and then next this extrude will do what, you see that the material over here has vanished. You can see over here that the material over here has vanished because we have used the operation of intersect, that the extrude of the circle and the cylinder should intersect, and only that material will be kept and other material will be taken off. After that, you can see that this part has remained, and this will hinder the piston from getting into the cylinder. And why it will hinder, we will get to that topic also in just next 1 minute. So what we will do, we use the trim feature and we will trim this body, and after trimming we will get this result. So reference will be this cylinder and the body to be trimmed will be 1, 2, 3 and 4, and you will get such a type of connecting pin whose face looks somewhat like this. Okay, चल, तो हम लोग यहाँ आ जाते हैं वापस। तो कनेक्टिंग पिन हो गया, अब आ जाते हैं हम लोग पिस्टन पे। Now coming to the piston. Okay, so the question of 20 mm has been resolved. यहाँ पे कितना था 20 mm, यहाँ 5 mm, यहाँ पे कितना था 5 mm and something, और यहाँ पे grooves बनाने हैं 3 for the piston seal rings। क्यों बनाने हैं वो भी पता करेंगे। टोटल लेंथ कितनी है 40 mm है, इसका टोटल ये कितना है, that is 80 mm। To be noted, it is 80 mm, not 81 mm, even though The connecting pin is of 81 mm. It is not 81 mm. Why? We will get into that also. So how do we make this? So first what we will do is we will suppress it just for the sake of understanding. Now we will make first of all we will make a cylinder that is 80 and 40. Okay, and we'll do okay. We will get this cylinder. After that we will make a sketch with a diameter of 80 mm and the inner diameter, another circle with the inner diameter with the diameter of 2 mm less, that is 78 mm, and then we will finish it. The constraint should be made that the both the circles should be concentric and the center should coincide with the origin. After that we will do extrude 4 to 4.5 and 5 to 5.5, whatever you want, just that it should have some distance between the groove that is displayed over here. ओके, तो उस हिसाब से हमने लिया है एक्सट्रूड 1, एक्सट्रूड 2, एक्सट्रूड 3, एक्सट्रूड 4, एक्सट्रूड 5. हाँ, एक्सट्रूड 3, 4, 5 में क्या है? बूलियन ऑपरेशन सबट्रैक्ट, ताकि वो ग्रूव बना सके. ग्रूव कैसा दिखता है ये भी आपको दिखा देते हैं. यू कैन सी दैट दिस इज अ groove. Okay, so these grooves are made. After that we'll make another sketch. We'll make another sketch that is perpendicular to this cylinder, and we will make it like a circle, and then we will extrude it and subtract it Boolean operation from this end to this end. We will use the operation of symmetry, not of that of value. We will use the symmetry operation 40, 80, and it will subtract 40 and 40 on either side. Now connecting pin can be inserted in the piston, as you know, as you see, but how will the connecting rod be inserted? Because there is no place over here to insert. For that, what we did was we made an extrude. We made a sketch first. The sketch is 10.5 mm. Why 10.5 mm? Because the extrude is for 20 mm. The connecting rod is 20 mm. So 10 and 10 in each side. We'll take 0.5 just for clearance and visibility purpose. After that, 30.5 mm is over here, because 20 mm is this hole, and this is 5 mm, and this is 5 mm. This is 30 mm. 0.5 I took because you are not able to see that if the connecting rod is getting like inside the piston. No, it was not getting inside, it was barely touching. So I made it 0.5 so that you can have a certain gap between them. So it looks good in an animation. And this is 9.5 because 40 minus 30.5 is 9.5. After that, what we will do, we will do an extrude, and that extrude will have the same operation of subtract, and the value will be symmetry. You can see, and 80 mm, and it will subtract over here. After that, what we will do, we will make an edge blend over here and over here. Okay, so if I had not taken this 10.5, sorry, if I had not taken 10.5, then this edge blend would not have been possible. This edge blend would not have been possible. Okay, so for that I took 10.5 so that this edge blend is also possible along with this edge blend, and this makes the piston complete. Now coming to the piston seal rings, there are various type of seal rings, uh, so we have not demarcated any symbols or any color for different types of seal rings. We have just made 3 seal rings for simplicity purpose, and we have made 3 seal rings. We have inserted 3 seal rings in the assembly. We have made only one. So made only one. How? We have taken 2 circles. Okay, we have taken 2 circles of 81 mm and 78 mm. 78 mm, वो उसका इनर वाला भी 78 mm था, तो उसके ग्रूव के साथ वो बैठना चाहिए, और ये 81 mm. और हमने क्या किया, ये दोनों सर्कल बनाने के बाद एक लाइन ली, यहाँ से यहाँ खींची, एक लाइन ली यहाँ से यहाँ खींची, मतलब कि हमने क्या किया था ओरिजिनली, एक सर्कल लिया था, ये वाला ऑप्शन ले लेते हैं, एक सर्कल लिया था और एक और सर्कल लिया था, और इसमें क्या किया हमने, लाइन लिया और यहाँ से यहाँ ऐसे बना दिया और यहाँ से यहाँ ऐसे बना, ठीक है। फिर हमने क्या किया, ट्रिम लिया, इसको ट्रिम किया, 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 इसको ट्रिम, ठीक है। उसके बाद फिर हमने क्या किया, इसका रेडियस ले लिया, इसका रेडियस ले लिया, ठीक है, और इसका रेडियस ले लिया, इसका रेडियस लिया, ये हो गया, ठीक है, इसका रेडियस लिया, ये भी हो गया, ठीक है। अब हमने क्या किया कि इसको और इसको क्या करना है, एक, अच्छा हाँ, हमने क्या किया था इसमें, ये मतलब इसका जो सेंटर है सेम एज दैट ऑफ द ओरिजिन है, तो हमने सिमेट्री का यूज करके क्या किया था कि हमें इसे सिमेट्रिकल रखना है, और इसको हमने सिमेट्रिक कर दिया था अलोंग दी दिस एक्सिस, ठीक है, तो वो सिमेट्रिक हो गया था। सिमेट्रिक होने के बाद हम अगर इसको मूव करेंगे तो ये भी मूव होगा, ठीक है। उसके लिए हमने क्या किया कि हमने इसको एक डिस्टेंस दे दिया कि तुम इस एक्सिस से इतने डिस्टेंस पर ही रहोगे, और जब इतने डिस्टेंस पर रहोगे तो फिर जाहिर सी बात है वो मूव करेगा नहीं, मूव नहीं करेगा तो बात खत्म हो गई, बस इतनी सी बात है। तो स्केच जो है वो फुल्ली डिफाइंड हो गया था। Now, after doing the sketch, we will extrude it in a very ordinary fashion for 0.5 mm, जो कि सील रिंग्स बहुत पतली होती हैं, हमने 0.5 mm के लिए एक्सट्रूड कर दिया और उसको बना लिया। और हर मॉडल को आप अलग अलग फाइल में बनाएंगे तो ज़्यादा अच्छा रहेगा, बिकॉज इफ यू वांट टू एडिट one model or one part without changing any other part, it is better to save each part in a separate file. As you see that all of these are separate files. I'll show you also that all of these are separate files. All of these are separate files. Okay. Now, coming to the last, cylinder. सिलेंडर यार सबसे आसान चीज, ठीक है, एक सिलेंडर लिया हमने, सिलेंडर बना लिया, सिलेंडर बना के उस पर शेल कर दिया, सिलेंडर कितने का बनाया, इन 81 mm का, और हाइट कितनी रख ली, वो तो भाई मैंने शुरू में 400 रखी थी, लेकिन फिर देखा 400 में बड़ा हो रहा है, 200 कर, ठीक है, 200 mm कर दिया, बूलियन कोई और ऑब्जेक्ट है नहीं तो उसकी जरूरत है। फिर हमने क्या किया, इसमें शेल कर दिया, शेल करने के बाद अगर मैं इसको पलट देता तो it will give shell on the inside, मतलब 81 mm will be outer diameter and the shell will change the inner diameter. However, if I reverse the direction, the 81 mm will be inner diameter and the outer diameter will vary upon this value. So I took a shell of 10 mm, ठीक है, और फिर हमने क्या किया, एक हमने alternate thickness डालनी थी, तो हमने क्या किया कि इस फेस को सिलेक्ट किया alternate thickness के लिए, क्योंकि यहाँ पे वॉल्स रहेंगी तो इसको थोड़ा सा पतला रखना पड़ेगा, तो थोड़ा सा हमने 5 mm रख दिया ताकि वॉल जो है आसानी से अंदर घुस जाए, ज्यादा लंबी ना हो, क्योंकि जितनी ज्यादा लंबी होगी तो उसमें फेलियर का चांस है, ठीक है। बस हमने ये कर दिया, शेल कर दिया, और फिर हमने क्या किया, हम चूंकि अब अगर मैं पूरा सिलेंडर बनाता तो जाहिर सी बात है वो असेंबली के मोशन में सिलेंडर के अंदर पिस्टन दिखाई नहीं देगा कि वो किस तरह का मोशन कर रहा है और क्या असेंबली प्रॉपर है कि नहीं। तो हमने एक सेमी सर्कल लिया स्केच बना के, और सर्कल का ऐसे स्केच बनाया, और ये अपना सेंटर रहा, और फिर हमने इसको एक्सट्रूड मार दिया, एक्सट्रूड मार के इसको बुलियन लगा दिया सब्ट्रैक्ट, तो उसने सब्ट्रैक्ट कर दिया, बस हमारा बन गया। So with this we come to an end of how all the different components and parts were made in Siemens NX CAD for IC engine, and you can see that all the components were made quite robustly and easily using the concepts. ठीक है, तो ये अपना था. And so this was the part 2 of the 3 video, and in the next video, part 3 of 3, we'll be dealing with the assembly constraints, as to how do we make the assembly constraints, and what and how do we know that assembly constraints जो है वो गलत है या ज़्यादा लग गए हैं, तो वो समझ में आएगा. So till the next time we meet, goodbye.